Hey Chemistry, Mrs. KJ here, going over lesson 3.05, metals. Metals have common properties. In this lesson you will learn about the elements known as metals. You will learn where they are on the periodic table, look at the properties that many metals share, and investigate some specific metals that are important in your life. Goals for the lesson: locate metals on the periodic table, give some examples of metals, describe properties of metals. So the periodic table groups some elements as metals. Do you remember the other two groups? Nonmetals and metalloids. So we're going to look specifically at metals, which are located in the left 2/3 of the table. So the left of the periodic table, the middle, and the bottom. And the properties of metals are shiny, malleable, ductile, and conduct heat and electricity. Approximately 3/4 of all the elements on the periodic table are metals. When you think of metals, what do you think of? Do you think of copper wires, titanium bicycle frames, and iron cookware? If so, you are correct. Those items are all metals. There are three different major groups of metals on the periodic table. There's the alkali metals, which is group 1, the alkaline earth metals, which is group 2, and the transition metals, which is the middle and the bottom. These specifically are called the inner transition metals, or the lanthanide and actinide series. You will study examples of each of these and find out what properties these metals have in common. Most of the elements on the periodic table are metals. The two rows of elements below the periodic table are the inner transition metals. Metals share certain characteristics. Metals share common properties. There are some exceptions, but for the most part, all metals share the properties below. In elemental form, so in other words, if you have the pure metal, most of the metals are shiny and silver in color. Most are solids under normal conditions. Metals share the property of malleability. Malleable materials can be pounded into shapes. Gold, copper, and aluminum are examples of malleable metals. So you can bend them, you can cause them to have different shapes. So metals are malleable, meaning they can be shaped into sheets or hammered into various shapes. Metals are also ductile. Ductile materials can be pulled into a long wire. You probably are familiar with copper wiring. Ductility is a property that many metals possess. So ductility is an important property of metals, allowing products like electrical wiring to be created. Most metals are good conductors. This means that they will transmit heat and electricity easily. So from the study guide, I kept the top paragraph and the goals. Our keywords and pronunciations: ductile, capable of being drawn out to form wires; malleable, capable of being hammered into thin sheets or different shapes. Metals are on the left, middle, and bottom of the periodic table. Most metals are shiny, silver in color, ductile, and malleable. Even though silver itself is an element, we still say that the other ones are silver in color or the other ones are silver-ish or silver. But silver is actually its own element. Alkali metals are those in group 1A. Locate the group of metals known as 1A metals or alkali metals on the periodic table. So if we look at our periodic table, we will see that the alkali metals are in yellow, and it's the group 1 except for hydrogen, because hydrogen in pink is a non-metal. It's only over here because it has one valence electron. But the alkali metals are the rest of group 1: lithium, sodium, potassium, rubidium, cesium, francium. The alkali metals, like all metals, are shiny solids and are malleable, ductile, and good conductors. And it says like all metals, but it should say like most metals. They also are all soft enough to be cut with a knife, as in a butter knife. When a new, fresh surface of these metals is exposed to the air, it tarnishes quickly. These metals are violently reactive. Alkali metals have one valence electron. You can tell this from their group number 1A, making them very unstable and reactive. The photograph and caption shows just how much care must be taken in their storage. Group 1A metals are so reactive that they must be stored in airtight containers and submerged in oil, because these are the ones that I showed in a previous video. If they are exposed to air, they will do what? They will start on fire. And as you go down the periodic table, they get even more reactive. So potassium's even more violently reactive than lithium because it really, really, really wants to get rid of its outer or valence electron. All right, so we're adding the alkali metals. The alkali metals are group 1A, very reactive because they want to lose their one valence electron to get a full outer shell and be stable. Remember, this is the key point of chemistry of why it happens. Also, under our headings of what metals are, I added that metals are usually a good conductor of heat and electricity. Alkaline earth metals are found in group 2A. So if we look at our periodic table, we're talking about the second group now, or second column, and specifically beryllium, magnesium, calcium, strontium, barium, and Ra. The alkali earth metals, beryllium, magnesium, calcium, strontium, barium, and radium, got their name from early chemists. These chemists called these substances that remained unchanged after exposure to fire, earths. These metals were similar to the alkali metals, and like them, were unchanged by fire. Since these elements reacted a bit differently than alkali metals, they were given the name alkaline earth metals. The alkaline earth metals, like the alkali metals, are very reactive. Calcium, for example, is often found in association with carbon and oxygen as it forms calcium carbonate, CaCO3, the mineral calcite. Calcium carbonate is also found in chalk and in rocks such as limestone and marble. Magnesium, another alkaline earth metal, is commonly found in seawater. You may be familiar with magnesium for another reason. It is the main component in many antacid products. Beryllium ore is an example of how some alkaline earth metals are found in nature. And so this shows some of the beryllium ore. The alkaline earth metals are group 2A. They are reactive because they want to lose their two valence electrons to get a full outer shell and be stable. Transition metals, these are the ones in the middle. Transition metals are probably what you think of as metals. The transition metals are located in the D block of the periodic table. So, in other words, the center, the middle. And it's called the D block because we talked very briefly about how the orbitals are called S, P, D, and F. If you listen to that one extra little lesson in the book that I went through. If not, that's fine, don't worry about it. You just need to know they're in the middle. These metals are probably the metals you thought of first when you started this lesson. Iron, silver, gold, and copper are all transition metals. There is great variation in the properties of these elements. Generally, the transition metals have high melting points and are very dense. Osmium and iridium are the densest of all elements at 22.57 grams per centimeter cubed and 22.42 grams per centimeter cubed, respectively. Do you remember what the density of water is? 1 gram per centimeter cubed. So these are 22 times heavier. So if a gallon of water weighs, or gallon, I know a gallon of milk. A gallon of milk is about 8 pounds. So a gallon of water is about 8 pounds. So 1 gallon's worth would be 176 pounds if you had osmium or iridium. Tungsten has the highest melting point of all the known elements. This means you have to have temperatures of 3,422 degrees Celsius before you can melt tungsten. Very, very strong as far as its melting point. So silver, gold, and of course copper. So I added to our notes transition metals in the middle and bottom of the periodic table, high melting points, and are very dense. Titanium is a transition metal. One metal that is part of your everyday life is titanium, abbreviated Ti. Element 22 in group 4B. If you wanted to mine titanium, you would go to parts of North America, Australia, Scandinavia, or Malaysia. Titanium, when added to other metals, creates unusually strong alloys. Alloys are mixtures of metals. These alloys are used in everything from golf clubs to razor blades to rocket surfaces. Other common uses include jewelry, sunglasses, implants to strengthen bones, and the bodies of jet airplanes. Titanium drivers are used in golf because the metal is both strong and lightweight. Implanted into bone, titanium serves to connect and strengthen bones and joints. Titanium is able to withstand extreme forces and heat, making it a valuable metal in the aviation industry as the hull of this airplane. And I added that alloys are mixtures of metals. Aluminum is a metal found in group 3A on the periodic table. As you are probably aware, aluminum is very malleable or very bendable. It can be hammered or molded. Aluminum is used in soda cans, pans, and aluminum foil. Aluminum has a low density in contrast to many of the other metals, but can be very strong when mixed with other metals. And when you mix them together, of course, it's called an alloy. Aluminum is abundant in the Earth's crust. It is the third most abundant element. Most of it is found in an ore called bauxite, along with oxygen and silicon. Aluminum is the second most widely used metal, after iron. Aluminum is heat resistant and malleable, and is perfect as a cooking surface. Aluminum is relatively lightweight, which makes it ideal as a container. Lightweight but strong mixing bowls are made of aluminum. Copper has many uses in our world throughout history. Copper, a transition metal, is a soft metal. Although soft, it has other properties of metals including malleability and ductility, so we can hammer it into shapes and we can pull it into wires, and it's a good conductor. Copper is widely used. The blue fireworks you may see exploding on the 4th of July or New Year's Eve are blue because of the copper compounds. Pennies in the United States were made of copper before 1982. Copper is a useful material for wires because it is very ductile and conducts electricity very well. In fact, only silver is a better conductor. They stopped using copper for pennies, and now the insides of pennies are all zinc because zinc is much cheaper. Copper does not corrode easily, but it does tend to tarnish. Old pennies often have a greenish tint. The Statue of Liberty is made of copper and is tarnished to a greenish-blue hue. This greening is called verdigris. So think about the Statue of Liberty. Every picture we've ever seen, it's greenish-blue, but imagine what it was like when they first made it and it looked like this. Copper can be made into tubes and is used in fittings and plumbing because of its property of malleability, meaning you can bend it into shapes. Like many metals, copper can be used to color paints and even the night sky in the form of fireworks. Copper combines with oxygen to form its own version of rust. So it's not rust because it's not iron, but it's still tarnished. This tarnish forms on most copper surfaces. In general, metals are solid, malleable, ductile, and good conductors of heat and electricity. The metals are a varied group of elements. You looked in depth at 3 groups of metals on the periodic table: the alkali metals, alkaline earth metals, and transition metals. There are other metals as well, as nearly 75% of all elements are metals. Metals vary in specific properties and uses, but have many applications in our everyday lives. Periodic table. Some group of elements are metals located in the left, the middle, and the bottom of the periodic table. Properties, they are shiny, malleable, so you can hammer them into shapes. Ductile, you can stretch them into wires, and they can also conduct heat and electricity. All right, that's it for this lesson. When you're ready, take the quiz.